Yeah, thanks for having me, Bobby. As she said, my name's John Engel. I recently moved into the role of Editor-in-Chief of Clarion Events' transmission and distribution, as well as renewable portfolios. And so as part of that, I lead the content strategy and execution for Distributech International, as well as the DER Interconnection Event Grid Tech Connect Forum, and our media platforms that cover the industry, Power Grid International and Renewable Energy World. I also host 2 podcasts for those who listen to podcasts. So I'm involved in conferences and podcasts, the 2 things that we needed more of. And I appreciate that role. Thank you for having me. And as Bobby mentioned, our panel today is EVs, DER, and AMI 2.0. Oh my. Being responsible for organizing a lot of panels like these over the years, we are often trying to get creative and be ambiguous just enough to get you in the room without you knowing entirely what we're going to be talking about. There's no ambiguity here. I think it's very clear on what the topic is today. The rapid deployment of distributed energy resources and the integration of electric vehicles brings us to this critical juncture where an aging infrastructure is meeting the demand for improved reliability, more bandwidth, and this critical transition that we're now in to AMI 2.0 is not just a hype cycle. It is underway and will be more magnified over the next probably 3 to 5 years. So this panel is very well equipped to tell you what it is, what it isn't, what to believe, and what to focus on here as we make this transition. With that, I will introduce our panel and let them tell a little bit about themselves and their area of expertise here. We have Rich Cregan from Anterix, Steve Morrell from Itron, David Helinski from Black & Veatch, Chris Traybold from GE, and I don't believe we have Carlos today. So, well, Carlos sends his regards. I'll let you just kind of go down the line here and give a little bit about your background and your perspective here on this topic before we move forward. Steve, you want to get us started?
Sure. Is that working?
Yeah.
Thank you. Yeah, so I'm Steve Merrill, and I joined Itron about 6 months ago. I come with a long history of radio communications background from the defense sector in the 80s and 90s onto fiber optics and then LTE stuff more recently. And so at Itron, we're focusing on providing outcomes for our customers, and those outcomes are centered on AMI 2.0, and it really is here, and it really is powerful, and it really is going to change the way the grid is operated, because it's a bringing together of the IT and the OT sides for where you have AMI data that's going to be used on the DA side, and then behind the meter on the DERM side as well. So we're really excited about this transition. There's a lot to do. It's complicated. But we're happy to be part of the journey.
Is that on? Yeah. So I'm Rich Cregan. I'm Senior Vice President with Anterix. Had the opportunity to go long ago and far away, back in the days of moving from mainframes to minis to PCs and consolidated data out into lots of places within companies, and we're kind of on that same journey, right? We're moving stuff from centralized to decentralized. Along that journey, I had a long time to work with my friends at Itron, led their advanced technology group during the AMI 1.0 days, so lots of experience with mesh and how we changed the regulatory framework, lots of work with working with deregulated markets, both here and overseas, led Census's advanced technology, their energy group with gas and electric, and now have the opportunity with Anterix as we think about how we're changing the dynamic of communications and how that changes the way we're going to deliver energy. So I appreciate being here.
Thanks, Rich. David Helinski, Black & Veatch. I've been with Black & Veatch. I was just thinking, while Rich was talking, I've been with Black & Veatch for now 24 years almost. Well, it's over 24 years. And it's amazing how fast time goes by. But the thing that I've enjoyed of my career at Black & Veatch is supporting our clients with very challenging projects, technology, as well as deploying those type of different technologies over the years. I remember my first project when I got hired at Black & Veatch was to deploy metropolitan area networks across the U.S. It was LA, New York, Manhattan, Miami, Florida. It was great because the technology that we're deploying was DWDM. It was brand new. It was fantastic. All the newly hired grads wanted to work on that project because we wanted to understand the technology. But it's been great to see that technology evolve, and now our utility clients are deploying it commonly for private networks. And that's the same thing with LTE networks. I've been able to be part of that over the last 10 to 15 years, deploying those type of networks for carriers, and then taking that technology and applying it to the private networks, such as the utility markets. So it's been a great, satisfying, exciting career deploying these different technologies and how this now really applies to the private network sector.
And hi, I'm Chris Straywold. I lead GE's communication product line inside of GE's grid automation portfolio, so collection of businesses that are automating the grid for the future. And for me, this topic is as much, about AMI, DR, of course, EVs, but about the network enablement that's core to make that happen, right? And that also enables other applications outside of those three, like for many applications of the grid of the future. So looking forward to participating today.
Excellent. Well, it's great to have all of you up here, and I think we should do a little bit of stage setting too as we talk about where we're at in the transition that we framed up kicking off this panel. David, do you want to provide a little bit of color on, you talked about being a part of that evolution over the years, but where we stand in this move into private networks, AMI 2.0, and maybe give us a starting point here before we dig in.
Yeah, it's really all about the data, being able to transport that data and having the technology to be able to assess, compute, do the analytics to that data, and then most importantly, sometimes commonly forgotten about, is how to reliably transport that data. And it's amazing to see that we went from kilobytes to megabytes to gigabytes, just even in the utility domain. And being able to have a network that will be able to support that is very important. I remember looking at the use cases back in 2008. AMI was pretty much commonly overlooked. It was a use case that needed to be supported, but very low bandwidth. Now, a meter, there's studies out there, OEMs, in order to enhance the customer experience, is sometimes these meters are projected to draw up to 1 megabit per meter. And if a customer has 5,000, if a utility has 5,000 or 5 million customers, that's a lot of data just in that itself. So having a very reliable, robust network and making sure that you can scale from 4G to 5G is very important.
I appreciate that context. So traditionally, if we take a step back, communications networks were set up in a vertical fashion with networks serving certain purposes. Why was that the initial approach? Anyone want to take that one?
Yeah, I'd be happy to take that. Generally, it's because of the return on investment. And so everything is sort of stovepipe because each network stands on its own 2 feet from a return on investment perspective. And whether that's the land mobile radio system or the AMI, mesh-based AMI solution, or the fiber optic networks, each one of them has this very specific purpose that meets a very specific set of requirements, and those requirements sometimes overlap, sometimes they don't, and it makes it really challenging. And so the goal is to, with LTE, is to be able to bring some of those communications technologies together to satisfy the requirements of multiple use cases. We're not going to ever have a single network that can support all utility requirements because the requirements are just so diverse from a technical standpoint. But we can certainly have a reduction in the number of networks with LTE because it has the ability and the bandwidth and the things that David said to support multiple use cases and applications for the utilities.
Yeah, Steve, I guess the thing I would add is that the consumers of the data, the people who need to get the data, is ever expanding. And so, as we had vertical networks that were, basically built for the purpose, proprietary, highly tuned to the purpose that they were supposed to do. It was a meter to cash problem in AMI, right? It was all about getting bills out the door. Well, we saw that get expanded, into remote shutoff, into outage detection. We had one utility, by way of example, who was able to use the day-ahead forecast, to completely fund the development of the AMI system, right? So the users of that data are getting wider and wider within the utility on where we need to deliver it to. And then the interaction of the devices themselves is becoming much more important, right? And so, the way the coincidental demand on a particular feeder is used in a VVO application or those sorts of things, it's no longer a single application for a single consumer of data. It's much more enterprise related today than it would have been before.
And I would just add that, historically, they were built in the 90s, early 2000s, and the technology just didn't support, what again today with these high-speed IP networks. So, 9.6, 19.2 kilobit serial networks was all you could do back then. And as well as utility structure of these vertical applications is kind of how we got here.
So then what are the technical limitations, or technical challenges rather, to moving to that broader functionality on a single network?
I'll be happy to take it. So, there's a ton, right? The utilities have a whole set of business requirements, and those business requirements are things like security that we just heard a great panel session on, change management, the ability to scale, fundamentally the ability to control the network. And AMI 20 years ago was solved all of those business challenges. And then you have a set of technical requirements for each of the use cases that a utility may have. Again, land mobile radio is very different than DA, which has very low latency requirements, and AMI has very low data rate and is latency tolerant. So that we have this very strict set of business rules and requirements. We had one technology that could solve it. Fast forward to today, and now we have LTE that also meets private LTE that meets those same business requirements. Then you have the technical challenges of the different use cases, technical requirements, and then layer on when you're doing radio, there's constraints in the radio environment, propagation characteristics, radio noise, interference, all kinds of things, and so it becomes a very, very challenging problem. And I counsel the utilities that the best approach is an all of the above approach, but with the goal of trying to minimize the number of network technologies that you need. But you're still going to need fiber. You're still likely going to need mesh in certain circumstances. You can try to put as much as you can on your LTE network, and you can put a lot on it. But it's really this all of the above strategy, in my view.
So I would say it's the technical challenge, given the ubiquity of the technology as we move to LTE and adopt global standards, is not nearly as big as the operational and business challenges, which I think you were referring to, Steve. So, we've all been blessed with having a built-for-the-purpose network that served my needs, and I didn't have to collaborate or cooperate with anybody, right? And so, now we're talking about a multi-purpose network that serves multiple users. So, we need to think about what is the governance that we're going to use. QoS is a great thing. We have the ability to do low latency, and we have high latency. So how do we arbitrate all of those business rules to be able to meet all of our customers' needs within the utility? To me, that's the bigger issue. The technology is great. When we went through AMI 1.0, the golden ring was IP, right? And if we could all just get the IP, we didn't have to worry about the MAC-PHY layer. All we had to do was worry about the application layer, right? Now LTE is basically that IP journey. We're moving up a layer where we're going to unlock a tremendous amount of innovation and development, because you're not going to have to worry about the transport layer, right? You're putting it on a transport layer that everybody understands. All of that investment that can now move to an entirely different place in the stack. So I'm not as much worried about the technology problem as I am worried about the governance, the sharing, taking the different operational silos within utilities and how are they going to collaborate to meet all of their business needs and the needs of their customers. So a little different from a technology requirement, I guess.
No, I like to add to Rich's. It's build it once, use it many is a common theme we try to look at. When we've done several assessments for utilities, and sometimes my aha moments is once we do assessments, and sometimes it's a surprise to our customers as well, is we do an assessment to see what the existing state is, and sometimes we find there's 10, 15, sometimes 20 separate networks over their organization, different business units, that's supporting the operations of the utility. That means you got 20 different spare part plans, you got 20 different change management plans, you got 20 different security plans, you got several different skill sets required to support that network. So when you really take a look at it from a holistic perspective, the case makes itself to build one common network, just make it more reliable, and it's so much easier to manage, and what's most importantly, with the security concerns, just making sure that it's, you know, you can transport that data securely. One security plan instead of 17, 20. I mean, it was just amazing with the total cost of ownership and how it made the case itself.
Yeah, and just adding, I would agree with Rich in terms of, I don't think it's really a technology problem anymore. I think that we have a very good foundation in LTE. It's governed by standards, 3GPP, a very good regulatory framework with the FCC, CTIA. There's plenty of standards that help govern the ecosystem. I think the challenges are more on implementing and the workforce, the skill set. And I think the good news there, and one of the changing landscapes, is there's more utilities that have done it now versus, say, 3 years ago when there was just, the poster child of Southern Company who had successfully implemented a private LTE system. And there's a growing, vendor ecosystem supporting these standards, as well as, consultancy PCs to help utilities really enable these future networks.
I think the journalist in me likes to point to this question of what it is and what it isn't, and I put that in the setup a little bit because I think it's important to not only look at the vast opportunity and all the good innovation that's taking place, but to also acknowledge where we stand and what we still need to overcome. So I'll put that up to all of you, and I invite you to be kind of candid in that space. What is and what isn't AMI 2.0, and what are some of the things that you hear in the market that give you pause or maybe lead you to interject a little bit? We talked about buzzwords in the last panel as well, but I think that's helpful.
I just wanted to add on to David's point just before. I apologize.
Yeah.
But the other theme here of multiple use and being able to share is the mutual aid problem, right? And so the more we're dealing with a global standard, the more we have devices that can move quickly from one utility to another, that our meters are not, proprietary, or a smart transformer, can be moved over, that we can move people over under LTE. I just, internally it's huge, but when we think about mutual aid, it becomes really, really big in terms of how fast we can respond. So sorry.
No, I'm not going to let you avoid the question though. So now you get to lead our myth-busting answer here and get us started.
So I think we at Anterix have tried to bring together, number one, the ecosystem. I think the ecosystem is a critical piece, making sure that this is truly, it does take a village, and we've seen lots of technologies get started, but without broad adoption, that's a real issue. So I think the ecosystem is critical. We've tried to bring together our Anterix Active Ecosystem, now more than 100 companies that are looking at use cases and not just, how do we interface something to each other, but how do we interface something together to deliver a business value. And so I think one of the things that we need to make sure we're focused on, lots of IT people here, lots of telecom people here, not lots of operations people. So we have to be able to serve our customers, we have to serve our internal clients, we have to show them, we have to demonstrate to them that we have the capability of supporting their needs. And I think that's one of our biggest challenges, is to bring the operations people into the fold and really look at that and get their confidence that we're going to make this significant investment and it's going to be something that's going to meet their needs tomorrow. I think that's probably our biggest challenge today.
Chris, any thoughts here? You look like you're itching at this one.
No, not really. I'm probably the least qualified to speak about AMI 2.0 as an equipment vendor. But I would say, from us, it's really all about the connectivity. It's certainly moving towards, LTE under the glass, and just having a network that can support that, including edge devices and backhaul devices on top of AMI devices under the glass is how my perspective on what AMI 2.0 is.
Yeah, and for me, AMI 2.0 is all about adding intelligence at the edge and the meter itself, and adding an app layer there, like an app store for Apple, and that's what we're doing at Itron. We have multiple apps that can do things like location awareness, high impedance detection, transformer monitoring. So there's just things that are just not traditional. Have the ability to identify each of the meters behind a given transformer, so you can look at the transformer, the load on that transformer. And so those are the kinds of outcomes I was referring to that we're really focused on at Itron. And we kind of view the network as a data pipe. It's critical. Don't get me wrong. It's absolutely critical. But the big piece of value is coming from all that data that's coming from the edge that can then be fed back into the other processes. And Rich is absolutely right. It's going to be a challenge challenge to bring those OT guys together with the IT guys and give them the opportunity to use that data in a way that helps them manage their Volvar optimization and do their, cap bank controllers and their reclosers and all the other things that's going to be possible. So this new set of data is going to open up the doors to a whole range of possibilities to change how those operational guys manage the grid. So.
When you and Rich both mentioned those silos that exist and needing that full ecosystem to come together, what can you do and what are you doing maybe to try to bridge that gap between those groups? What are some techniques that we can take away there?
You want to take that one? Yeah. You want?
So I think first of all, this is a great venue, right? I mean, what we're doing here today, what we're doing with the Plugfest, all of the vendors coming together, input from all of the utilities. Speaking with one of the other vendors, we need to step this up in the years to come to really think about the business problems, the implementation problems. Again, we're all here to serve our internal customers, right, and make sure that they're successful. And so I think that's, that we need to keep that first and foremost. This isn't about technology; it's about enabling the utility to serve its purpose, right? So that's, I think, the active ecosystem and the work we've done with the Anterix active ecosystem, trying, as the unfortunate thing, from a technology perspective, the utility industry is not big enough to drive technology. We've tried to do it for a long time, and we can't get the chip manufacturers, we can't get the folks to build their roadmap. So this is a great opportunity for us to utilize technology in the world as opposed to try and build and sustain. For years, I remember going up to the old meter plants where they turn their own wire, right? So I think that's the more we can do that collectively, the more we can do that collaboratively with our utility partners and with the vendors that's probably job one. And I think the other piece of that, sorry to go on, but we've had, and frankly, I referred back to the PC environment. A lot of businesses, a lot of business units went out and bought PCs because IT couldn't respond to them fast enough. Well, we have the same thing happening. A lot of your operational folks are going out and putting stuff on public cellular because we can't respond fast enough. How do we bring them back? How do we show them that our internal communications, our internal teams can support them with what they need to do, I think is our big challenge.
Excellent. And before we move on, I know we still have some time left, but as you're thinking of questions, I think if we have time at the end, we will be able to take some questions from the audience as well. Are there any regulatory considerations here for utilities as they're undergoing this transition into AMI 2.0 that we need to bring up? What do you guys think?
Well, I've done a lot.
I mean, there's all kinds of regulatory issues and so forth from deploying these type of networks. Everything from permitting, the environmental, just the infrastructure implementation to the spectrum. Commonly, and I might back up just a little bit on the AMI 2.0 because it's amazing how we learn over our careers. AMI was just really trying to accurately pull meters. But I just read in the industry, it was over $20 billion of energy losses just in distribution lines alone. So AMI 2.0 is really helping make our distribution lines significantly more efficient through VoltVar. Every minute that the distribution line is not optimally performing, I mean, it's money lost, it's energy lost. And so being able to pull those meters on once every 60 seconds, once every minute, again, that impacts the amount of data, but also the benefits of that is you're able to control the voltages in order to optimally control the efficient flow of power and so forth. And that goes back down to, deploying networks as well, the regulatory issues, and sometimes that's commonly overlooked when you're deploying networks. Sometimes we focus on the technology. And what we've done over the years, deploying LTE networks for carriers and now for utilities, typically about 70% of the risk of deploying a network on schedule, on budget, is really around the regulatory, the construction aspects, the infrastructure aspects, more so than it is the technology itself.
Just end with, I guess, from an equipment standpoint, of course, there's the typical, FCC carrier certifications. I think there's, though, great emerging things like, the CTI standards, the Anterix active ecosystem, things that can help the utilities feel comfortable that they're buying from a large, vendor ecosystem, certified deployable devices, and don't have to be concerned about proprietary solutions.
So let's move on to affordability and reliability, kind of core tenets of this industry. Help us better understand the cost considerations between private networks and public networks, and what utilities should understand about, how that all pencils. Does anyone want to take that one?
Yeah, sure. So the private networks are going to be obviously, super expensive to deploy. Large capital projects. We had LT from U.S. Cellular accurately point out that a single cell site is somewhere between $600,000 and $1,000 and $1 million just for one. That's not counting your core and your network management and your operations and all of that. So the TCO for a cell network is going to be high, but the benefits are also going to be really, really high. So, they have to think about, what those benefits are, and they have to try to quantify them. And most utilities in their rate cases today are using distribution automation for the reasons that David pointed out a moment ago about the volt-var and the energy lost, because the data can come back and help them do a better job managing those transmission lines and providing the return on investment for those big assets. On the public side, the big challenge is the longevity of the public networks. The cost, of course, is important, but we've all been burned by the sunset of 2G, 3G, and 4G sunset's going to come, whether we like it or not. We have to protect ourselves against that. We have 20-year assets out in the field, and those assets have to be operational for that period of time, and we can't be rolling trucks to change modems, 12 years into a 20-year depreciation schedule. So those are the sort of considerations and the trade-offs between and amongst them, and the things that we're doing at Itron is to try to provide longevity with carrier partners, getting contractual agreements to give us longevity for certain technologies, providing 5G modems in our access points and, to enable migration to 5G when 4G does sunset. So there's a lot of considerations to think about when you consider public versus private. So private's going to put the utility in control, and I think that's why we're all here, because it really is a great technology, and it's gotten much lower in cost over the years, and the ecosystem is rich with devices. There are so many devices and chipsets. We still have challenges with that, as Rich has pointed out, and that it's fantastic that Anterix has pulled together this ecosystem to help address some of those challenges, but the challenges will be even greater with 5G. So yeah, lots to consider when you're thinking public versus private, but private is certainly going to put a utility in control, and again, that's why we're here.
There are certainly big investments, no question about that. AMI was certainly a big investment for most utilities. There's no question about that, and the rate base was able to absorb it for the right reasons. We're in the middle of an energy transition that's got to completely change the dynamic of how we deliver and use energy, at the same time that we got to prepare for 5 to 6 more times the energy flowing through our systems. And so I don't know how we do that without the utility having the control it needs to, again, support the community and the infrastructure it needs to do. So I just, to me, there's really not an option. The utility gets back to the regulatory piece. What is the role of the utility in this place, and enabling and bringing to market the capabilities that we need to get? We didn't talk about DER, we didn't talk about EV. How are we going to integrate all of those things without having a communication system that's reliable, that's controllable, that's secure? Yeah, it's a lot of money, there's no question about it. The rate base, the utility structure of this country is built for long-term investments, and so I think we just need to think about that as then a trade-off of what comes first, and how do we make those investments where at the same time you got to upgrade and change all of your transmission and all of your feeders. You got to think about communication. So there's big decisions to be made. But I'm confident. I've worked with utility leaders for a long time. I'm confident that the right decisions are going to be made to make this transition.
Chris, David, any thoughts here?
I was just going to say, at the core, utilities want to own and operate their networks, right? They always have, and they would like to do it, going forward. And they've been somewhat skeptical about, what the operators, the cellular operators can offer them. And I think there are some changes coming, network slicing and 5G. There might be some opportunities to continue, but I think, at the end of the day, I think private is really where the utilities want to be and probably should be. And I think to do that, of course, the cost, as already described, is pretty exorbitant, but the payback is also there. And the payback's not only in network and efficiencies and condensing networks, but then, some societal benefits like rural broadband and things that come along with it that maybe aren't as easy to monetize.
Yeah, I may add that utilities own their own generation, their transmission, their distribution. Transmission, the primary grid, the first grid, distribution, the second grid. Now network communications, because it's so important and it so much impacts the bottom line from a productivity, reliability aspect, it's commonly referred to as the third grid. So if you own your own transmission, if you own your own distribution, kind of the weakest link is do you need to own your own private communication system? And the common denominator is yes. Being able to have full control, have that VIP status to be able to ensure that your operations are meeting your customer needs is very important. However, there's a play for public networks. Have the private network as your primary means of communications, but then use a public network as redundancy means, resiliency means, backup, extended coverage, or if you're taking your private network out for maintenance purposes, there's a purpose or a reason that you can use public networks.
Excellent. Okay, so we got a few minutes here before we'll get to questions, but I do want to give you guys all the opportunity to offer some final thoughts here and what you think the main takeaways should be for our audience here today as they're taking this information back to wherever they're going. Steve, do you have some just kind of wrap up thoughts here and what you think the main points are?
Yeah, sure. So, what David said just rings true, so that you can leverage, utilities can leverage the public infrastructure for backup purposes. And it goes back to what I said before, is that you still need to take this all of the above approach. Even if you build the private network, you're going to want to have some degree of resiliency that you might get from a public network. You're going to, deploy a substation, and maybe you have fiber there, maybe you have microwave, maybe you have something else to provide the connectivity, maybe you use cellular. So, it's really, it's a challenging technical, and to the points over here, it's also a challenging operational, integrating the operations and the IT guys into one umbrella where they have not been, and managing the security of multiple networks. All of these are big challenges. And I think this group working together to help the utilities through all of those challenges is a great thing. And Bobby's done an amazing job with this organization, and I think this organization is just at the forefront of helping the utilities through those business and technical challenges. So,
Rich?
Yeah, I harken back to, this isn't a technology challenge. We all know it works. It works on our phones all the time. I talk to utilities, and we don't need to do pilots on the technology. We need to do pilots to understand how we implement. We need to do pilots so we can learn how to operate. We need to do pilots so we can understand the operational impacts of these things. But it's not a technology issue. I think it's very much an operational issue. It's very much about bringing back our internal clients to get them to rely on us and trust us that this is going to be a good investment. You talk about the amount of money that we're asking for. That's something that we have to gain the trust and the confidence of the user community. There's going to, if we build it, they will come, right? So I think those are the bigger challenges. I think we need to think about that. I'd also encourage folks to, have conversations with David and his colleagues, because this is all about a technology roadmap, right? So we're going to build something, what is the obsoleting technology? What are the things that you're going to change in the next 3 to 5 years? What are the platforms that are becoming obsolete? If you don't have a strategy in place, you're going to replace like for like, and you're just going to replay the same tape over again. So I think the governance, understanding the confidence of our internal clients, thinking about that technology roadmap, and how we all can get together and continue the journey that our 5 customers have started on. How do we leverage the lessons of those folks who are out there pioneering the way with some of this private LTE?
And can I just respond for a minute before you go? Just to Rich's point, the technology is there. I don't disagree with that. I totally agree. And our cell phones and everything works. But, you know, LTE and 3GPP standards are the most complicated radio standards in the history of mankind. Since Marconi came up with the standards, he was sending just Morse code back in 1905. We've moved to, single carrier FDM on the download, OFDM on the download, and single carrier FDM on the upload. Incredibly complicated transport protocols through the network, authentication and security. So these networks are not for the faint of heart. There's a lot of technology to be understood, and it's complicated, but it's there, it works. And so the question is how do you leverage those technology features, minimize what you have to expose, tune it down, as some of the other speakers on the other panels have discussed, so that we use a minimum subset of LTE to meet the technology challenges and the business challenges of our customers.
Yeah, probably three takeaways for me is it's essentially the private network is the third grid. And we all have to realize that. And it's that important that it needs to be taken into account from strategy to planning and so forth. The second thing is build it once, use it many, just like we were talking about today. Not 17, 20 different networks that is not sustainable to be able to operate and maintain. And then operations and maintenance. After you deploy that network, you got to have an operations and maintenance plan in order to preserve that reliability and so forth. So having a trained staff with a good change management plan and a cybersecurity plan is ultimately important.
Always tough to go last. Agree with all those guys, and I would say the three for me, I guess, would say the technology is there. We talked about that. I don't think there's any debate about that. Horizontal versus vertical networks is definitely the way of the future. And then I would say just encourage the group to use the ecosystem of vendors, utilities that have already done it to help with your implementation going forward.
Okay, excellent. So before we get you all to your coffee break, questions from the audience for our panel. Please come up to the microphone and introduce yourself and let us know what you think. Yes, sir.
Good morning.
Morning.
Ryan Chattel from Schweitzer Engineering. So question, you guys talked about kind of the OT and IT convergence and the importance of securing, kind of owning that infrastructure, having security. How would you convince a utility who might be afraid of letting the outside in, especially as we get into, penetrating into the enterprise level? How do you convince them that cloud is secure, that public failover is secure? I'd just like your thoughts on that.
What are you guys saying?
I'll go. So, we just had a panel on this topic and on the zero trust security models, and those panelists did a great job explaining many of the challenges. For us at Itron, we sell end devices, user elements for the LTE networks. Those user elements come with secure elements inside that are personalized for the device, so we can do secure enrollment, and that enables us to then set up secure, trusted TLS sessions, and then roll keys and transfer those keys over to the ownership HSMs that are housed at a utility if they want to house those HSMs themselves. So those are the kinds of things we do to ensure that we have a trusted environment for our customers and our devices. And of course, secure bootloaders and all that stuff on the devices that the guys talked about before is critical to all of it. So.
Yeah, and I would just say, from our perspective, we are definitely helping the OT groups transition to the IT and to the enterprise, right? So, for us historically it was only OT. Now we're finding ourselves in discussions with security groups. How does it fit into their routing schemes and protocols, and providing that expertise to the OT team to help in some cases participate with their IT teams has been proven successful. To your cloud question, I think that's still a tough putt for many utilities. Sometimes we recommend on-prem first, and then but I do see a loosening of acceptance of eventually moving to the cloud. I think there's enough security, enough use cases that we're seeing a little more willingness to accept that kind of a solution.
Any other questions?
Yeah, hi, good morning. Lauren Goff, Director of Ways and Means, Women's Wireless Leadership Forum, and also Environmental Service Group Leader at Raymaker and Associates. So, Bobby, thank you for an amazing conference. This is my first time attending. And David, I think it was you that brought up something that I am interested, passionate about, and feed my family with, and that is regulatory and environmental. So back to basics here, right? We talk about using licensed spectrum in a PLTE environment, and we talk about the need for regulatory, and I'm talking about NEPA, Section 106, that's Environmental Policy Act, National Historic Preservation Act. We've seen some funding mechanisms, right, being created around this, and kudos for talking about the importance of starting early on that process, right? Something that could take up to 120 days to get through. But my question for you, sirs, is relative to the economics as such. So what are funding mechanisms that you're seeing that might help our utilities get through that regulatory and environmental process more expediently? And if not funding mechanisms backed by the feds or states, can you talk about monetizing macro sites specifically, perhaps for co-locatability, to kind of offset that essentially much smaller cost of making it regulatory environmental sound for licensed spectrum? That's a convoluted question, but thank you for the topic. I'll take my seat and listen. Thank you.
I'm the moderator.
No, that was great.
So
That was a great question, and we get it all the time. When should you start the environmental, the planning, the permitting aspects of deploying any network? And as we said, when deploying a network, 30% really is maybe the technology, all the different OEMs that need to be operatable and so forth, but really it's that construction execution plan. And when should you start planning for that? It's way up front in the strategy stages, making sure you understand, the type of towers you're going to be installing, the height of those towers, making sure you understand the jurisdictions and so forth, and being able to have a relationship. So what we did in order to give our clients surety around that we're going to meet schedule, that we're going to meet budget, is we acquired a permitting company to where they had relationships with the local jurisdictions, because that was so important to be able to understand what are the requirements, who are the ones that are making the decisions, making sure you get the information correctly in front of the ones that are making the decisions, and not giving them information that is maybe not correct the first time, and then it goes to the bottom of the stack, and then it wastes time and schedule and money to be able to obtain. Now, I like the idea of co-location as well. Utilities are really are taking advantage of that from a new revenue stream, building very secure, structurally sound towers and being able to co-locate that to carriers as well, so that potentially it provides the environmentalist and the regulatory a sense of mind that there's not going to be multiple towers built in the same location, to where there's a sharing of co-location, but then also it provides a new revenue stream for the utility, because they're managing the installation of those antennas and so forth on those towers in order to make sure their system is very reliable, but making sure it's meeting all the standards and specifications.
Yeah, it's the middle mile for rural broadband, right? And so we've got a tremendous opportunity to not only serve our energy needs, but also serve our social needs in terms of expanding that out there. And so taking advantage of that, doing that kind of planning, how can we leverage the work that we're doing? And then I'd echo, I've seen a lot of utilities try to do what probably they should bring in some experts to do, right? And so, if anything, these are very, very complex and complicated rules and things to get through. So I just strongly encourage you to think outside the box and who can do that, so that you can focus on the core piece of the business.
Yeah, and I would concur. I think finding consultants there, and there are many out there that do site acquisition services for large carriers. The way the large carriers do it is they hire somebody to find 100 sites in a certain area and go through the permitting for them for each of those individual sites. Each site is a challenge in and of itself, because every municipality has their own zoning and other ordinances, and then you have to go through EPA and various other regulatory approval processes. If you're near an airport, you have to put lighting. So there's all kinds of stuff that goes on in building and siting a tower. And the co-location piece makes absolute perfect sense. I mean, if I were deploying a private network, I would absolutely build in a co-location strategy and leverage those assets, because you can make a significant amount of money on those, as well as your fiber assets. I'd be selling IRUs and having maybe an unregulated portion of the business to do this piece, and it has the environmental benefits as well as the monetary benefits. Environmental benefits for the community, as David pointed out, absolutely the best way to do it. A long time ago, I wrote a zoning ordinance for my own town, and that's exactly how I wrote it. I said, you shall look for the tower that's already there. You shall look for a site, a building or some other colo site where you can hide the tower, so that we can minimize the number of towers that we have to deploy. So all of those are important considerations, and hiring the consultants, and there's a bunch of them out there to do this, and even the infra vendors, they know how to do this because they've been doing it for years for the big carriers. So.
Yeah, I think most of you are doing it already, but the other thing is just thinking forward as you're upgrading substations, as you're making those natural changes, is making sure that you're working along with your distribution engineering and your standards people to make sure that you're making that accommodation. I mean, there's some things that can be put into substations, not necessarily technology specific, but making them comms ready. And so how can you do that, in order to anticipate some of it?
All right, well, we're about out of time. Steve, Rich, David, Chris, thank you for a wonderful discussion here. Thank you for the questions, and please join me in thanking our panel for such a great presentation.